bit of hypothesis testing, but introduction to paired data and scatter diagrams. Okay. So we want to talk about making a scatter diagram. We want to be able to visually estimate the location of the best fitting line for a scatter diagram and visually estimate the degree of linear correlation. Okay, so we'll talk about what those things are. This might be the second shortest section of the year, next to 7-1. All right. First of all, a scatter diagram is a pictorial representation of paired data values using an XY coordinate system to visualize the relationship between the measurements. Sounds awfully fancy. A pictorial representation of paired data values using an XY coordinate system to visualize the relationship between paired data values, or relationship between the measurements. Almost the top of the morning there, Brady. Oh no, are you okay? Yeah. So like the left lane, like cars were coming, but the right lane, like you could still turn into them. So no cars were coming. So he started to turn. So I made one last check while I kind of was like rolling a little bit. I shouldn't have been doing it. And he like slammed on the brakes. And I turned. Like see him like slam on the brakes at the last second. Hit his hitch cap, like the little 40 buck hitch caps, like yeah. That aren't necessary that can make your car look better. And like that exploded, but there's no other data whatsoever. Like my car was fine. And then he was like, I don't know, we should call the cops. That's what I've been taught. And I was like, how old was he? He was 40. His name was like 40. He's like, let me call my dad really quick. And I was like, okay. So his dad came down, my dad came down. That's the right call though. Call the cops. I rolled into somebody at 2 miles an hour. Did I tell you guys this story? I rolled into somebody at 2 miles an hour, and old lady, like, well, old. She seemed old at the time. She was probably like 58 or something like that. She was like, oh, I don't want you to get in trouble. Let's not call the cops. It's okay. It's just, it doesn't look like there's any damage. Blah blah blah. Turned around and sued my family for $318,000. And there's no police report. So even though you're at fault, you still want to call the cops because then there's legal documentation of this is what happened. So, yeah. Yeah, 318,000. Or 327, one of the two.
Oh. Yikes.
Yeah. I don't remember if it was either 106,000 or 109,000 each. My mom, my dad, and myself. I was 16 at the time. Well, she claimed that that the accident caused a lot of medical damage, and she was having to have MRIs and CAT scans on her back and all this stuff. She had bills, like, for medical stuff. She also happened to tell her chiropractor that the week after this accident happened that she stepped in a hole. So they're also, when we went back to look at their car, like we went over just to discuss things with them, like the day of. 2 hours later, there was like this 6-inch long dent in their back bumper that hadn't been there before. Well, not at the time. I didn't have a camera. I mean, this was 1996, so. No. No. That and our State Farm agents, lawyers, or the State Farm lawyers that were dealing with our case, found that she had like 3 aliases, had been arrested for fraud and shoplifting and a couple of other things. And so they settled out of court for $10,000, which covered maybe 5% of her medical bills that she had. We didn't. Our company, or State Farm paid her that to settle out, but it was, yeah. But then they dropped me from the insurance, or dropped our family from the insurance, and we had to pay higher premiums and stuff. So, yes.
Anyway, but moral of the story, always call the cops, even if it's your fault. Especially if it's your fault. All right, line of best fit. Okay, so what we have here is we have an XY coordinate system, right? X-axis, Y-axis. Probably all remember that from algebra, maybe with not so fond memories. And what we're talking about is we're just talking about plotting points. So let's say, for example, you wanted to plot, or you wanted to compare a car's weight to its gas mileage. Okay, so you put cars' weights on the x-axis and gas mileage on the y-axis. And then for specific cars, you would measure their weight, how many tons they were, or how many pounds they were, and what their gas mileage was, right? And so each one would be represented by a dot, an x-coordinate and a y-coordinate. Okay? That's what we're talking about here. We want to look at the pattern in those dots. Okay, so in terms of what we're interested in is if there's a linear relationship or not, and what's the line of best fit? The line of best fit is the line that passes closest to each of the points in the sample. And we'll define that in a little more detail in the next section when we talk about the least squares line. But in essence, the line of best fit is the line that best approximates the data. It passes closest to the points in the sample. Now, there are a couple of obstacles here that we have to overcome when we talk about trying to come up with a line of best fit. Okay? The first one is determining what it means for a line to be to say that a line fits the data well. How do we determine whether or not the points on the scatter diagram are suited for fitting any line? Are the dots actually linear? What does that mean? Because most data is not perfect. You're not going to end up with all the dots being right in a row. For any 2 points, there is a line that passes through both of them. But for 3 points, there's no guarantee that 3 or more points, there's no guarantee that the points are collinear. So determining how well the points of the scatter diagram are suited for fitting any line. Is there actually a linear pattern there? The second obstacle has to do with, okay, if there is a linear pattern, then what's the mathematical criterion for this line and a formula for representing the line? In other words, how do we then come up with that line? Okay. So first, does the data actually fit a line? Is a line a reasonable approximation? And then if so, how do we come up with that line? So those are the two problems we have to overcome here. And this first section is going to talk about that first obstacle almost completely. Just do the data fit a line? Does the data? Do the data. Do the data fit the line? Plural. Oh, I actually cited some of my sources here. Okay. So, some types of correlation. Okay. Start with perfect correlation. Okay. If you have perfect correlation, then all of the points are on the same line, and then it becomes really easy to determine what the line of best fit is. You can draw a line through all of the points are collinear, you've got perfect correlation. Now, in statistics, that typically doesn't happen. But you could have high correlation. We'll talk about positive, negative correlation a little bit later. Okay, where all the points are really close to a line, you could draw a line through there that fits pretty reasonably well. Not all the points will be on the line, but they'll all be close to it. Okay? And we have varying degrees of this, right? Moderate correlation, the points get a little bit further from the line. It doesn't approximate a line as well, but you can still kind of see a pattern going from, in this case, going from left to right. The data is headed downward. Or low correlation, which starts to look a little bit more just like a cloud. Like, okay, well, there's kind of a trend upward from left to right here, but not really much help to us. Okay, so low correlation. And then something with none, where there's not really an up to down pattern as you go from left to right or down to up. it just kind of looks like a bunch of points spread out all over the graph. So we go from perfect correlation to no correlation. I would recommend, we probably won't go with moderate in here. We'll talk about perfect or high or low or none will be sufficient. Okay. And I would probably group this then in terms of high correlation because, I mean, you could look at a swath here where they are all kind of in that swath, kind of in the same corridor there. All right. Questions on the idea of correlation there in terms of what it looks like? Okay. All right, so let's create a scatter diagram for the set of data. We're going to draw a line that we think best fits the data and determine if there's no low, moderate, or high correlation here. Okay. So here's our set of x values and y values. We're just using a generic set of data here, just something I typed up. Okay. And the first thing we want to do is we want to consider our scales for our axes. Okay, so for example, our x scale goes up to 14. And I would encourage you, although the textbook will put a break in there, I would encourage you to try to not put breaks in your data as much as possible. Okay, it's really important for us to kind of have that, especially that y-axis, or I'm sorry, to not have a break in the x-axis. The y-axis as well, though, is kind of important here. So let's see if we can go from 0 up to whatever, and we'll deal just with quadrant 1 in this case, because all of our values for x and y are positive. X's go from 2 to 14, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I go by ones, I am not going to be able to cover this, so how about if we start, and we'll go by twos. So this would be 2, 4, 6, 8, 10, 12, 14, 16. Good enough. And then my y values go up to 30, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those. Let's go by threes here. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And now, of course, we're just going to plot the data. Okay. Now, I assume you probably know how to plot data, right? Our x-coordinate is our horizontal coordinate, and our y-coordinate is our vertical coordinate. So, for example, 2, 5, we're going to approximate to be right about there. 4, 9, and then I'll be quiet, and you can go ahead and do this on your own. And you should get a scatter plot that looks something like this. Any questions creating the scatter plot? All right, draw a line that you think best fits the data. So you might want a straight edge for this, school ID or driver's license if you didn't leave it at home, side of a phone, pencil, something. And you just want to kind of sketch in that line that you think is the best fit line, the line that gets close to all of the data. And I'm going to say that it's probably right about here. Now, it doesn't have to pass through any of the points that you plotted. Okay? You could have a best fit line, and a lot of times you probably do have a best fit line that never hits exactly on any of the points from the data. maybe something like that. And then our goal really is going to be, okay, well, it may not be exactly this equation, but our goal is going to be to write an equation for that best fit line, and that's what we're going to talk about in the next section. Okay, we're not going to do that here. Okay. But you did talk about how to do this back in Algebra 1, right? For a scatter plot. Best fit lines. And you should have talked about how to write an equation for it, an approximate equation, right? Find 2 points on the line, so maybe I use this one, and maybe I use this one right here, which isn't actually a point on my line. Okay, but maybe I use those two, and I find the slope between those 2 lines, and I find the y-intercept, right? Okay, and go from there. Okay. All right, now what's the next step here? Determine if there is no low, moderate, or high correlation. Well, in this case, what do you think about the correlation? Do those points pretty closely, or are those points pretty well approximated by a line, not very well approximated by a line, not approximated at all by a line? High, right? Those points are all pretty close to that line. So we would say, yes, there is high correlation here. And that, in essence, is what you're doing in the first section of the homework. Well, you're going to be creating some scatter plots, identifying it as high, low, or no correlation, moderate potentially, but you can probably go to the low side of moderate or the high side of moderate. Okay. Yeah. Questions there?